Okay, students, we're going to go over your practice test here. If you look right now at number 6, I had to modify it. So notice it's added on centered at 2, 2. Okay, so that's the center of dilation. Okay. All right, here we go. Number 1, ratio of angles A and B are 8 to 7. What's the measure of the larger angle? Well, we see of a linear pair here. You know all linear pairs are supplementary, which means they add to 180. We know we put an x behind our ratios here, so you have 8x plus 7x is 15x equals 180. Divide by 15 on both sides, and you get x equals 12. Then I need to find the larger angle. Well, that's going to be 8 times 12, which is then 96. And there's your answer. Number 2, segment AB has endpoints right there. Okay, so they give you the endpoints A and B, and they want you to find R that lies somewhere on it. It tells me that the number of parts from A to R is 1, and the number of parts from B to R is 4. So there's a total of 5 parts. Okay. So I'm choosing to go from point A. So I write down the coordinates of point A, 3 and 8. I imagine where B is, 6. That means it's to the right on the X coordinate. I start at 3 and I'm going to 6. So that's to the right. So that's why it's a plus here. And from 8, I'm going down to 2. So it's a subtraction. Okay. And how many parts is it from A? It's 1 part out of the total of 5. So I did the 1/5 method. Okay, and then that means it's 1/5 for both the X and the Y. And then how far is it on the X axis from 3 to 6? It's a total of 3. That's why you see 3 there. How far is it from 8 down to 2? 6. That's why you see 6 right there. Now I just put in the calculator and I get, or do it in my head, and get those 2 answers right there for X and Y, put it as a point. Okay. Now, down at the bottom you see here, there are more blanks, graphs on the next page. So if we go down here, go down to the bottom, I threw in 4 blanks down here. Okay, that you can use to do the problems on the other side. Okay, so I could have graphed that if I wanted to. On number 2, I had 4 graphs. Number 3, we'll go ahead and do this one. This is a trickier one. Actually, let's go back up and do number 6, so I can go down just go down the page. So number 6, to plot -4, 4 right here, and I plot that's B, and 6, -6, A right there. Okay. Now it says I'm going by a scale factor of 1.5. Remember, when I go out to the original point, that's a scale factor of 1. So I need to go half that distance again afterwards. Remember, scale factor 1.5 is greater than 1, so the image is going to be longer than the pre-image. Okay? Remember, scale factor is image over pre-image. Remember I told you the easy way to remember that is alphabetical order. I comes before P in the alphabet, so you know which one's on top in the numerator. Okay, so what can I do? I can use sort of like the slope. So I'm going over 1, 2, 3, 4, 5, 6 in the X direction and 2 in the Y direction. So now, therefore, I'm going to go over half of that because that's a scale factor of 1. So half of that would be 3 in each. So 1, 2, 3, and up 1. Okay, and there's going to be B prime right there. Okay, now I'll change the color. How do I get down to A? It doesn't matter if I go horizontal or vertical first, so I'll go vertical first. 1, 2, 3, 4, 5, 6, 7, 8 in the Y, and 1, 2, 3, 4 in the X. So that means I have to go down half of each of those. So down 4, 1, 2, 3, 4, and right 2, 1, 2. right there is going to be A prime. This A prime is off because I changed the problem. Okay. And so if I was to connect those two right there, that'd be 1.5 times that length right there. Okay. Centered at 2, 2. So you're using slope. So if it was a 0.5, I would go out to 1, like I did the 2 and 6. I go half it again, but I'd be coming in closer. So if it was 0.5, let's change the color here. Let's say I use purple. I'd be going down 1 and in 3. 1, 2, 3. Okay. And I'd be coming up 4. 1, 2, 3, 4, and in 2. And those would be, that would be my segment right there for half of it, centered at 2, 2. Okay. And remember, we can always check also to see if it makes sense, because when I line up my corresponding points, they should go right through those endpoints right to the center of dilation. And so you notice they all do right there. Okay, so I did a 0.5 one, the smaller one, and I did a 1.5 one. Okay, you're gonna have one of those, either a 0.5 or 1.5 on yours. Okay, it may not be centered at 2, 2. It could be centered somewhere else, but it's the same idea. Okay, and again, you can check it. If your answer makes sense, draw with your, straight edge, line your corresponding points up and see if they come back and run right back into that center of dilation. Okay, down to number 3 now. It says segment AB has endpoints A and B, negative 8, 8, and 0, 0. We'll go ahead and plot that on the back side here. Negative 8, 8, and 0. Oops, I'm not going to pen one. Negative 8, 8, and 0, 0. Okay, so it's going to hit somewhere along here. Let's move this back up the correct spot. Okay. Now, I'm going back here, reading the problem again here. Okay, notice, we haven't seen this one before. If the ratio of the length of A to B, notice it's A to B, the entire length of the segment is 4 parts. Okay, remember normally we'd have A to R and B to R. This is A to B now. The whole length of the segment from A to B is broken into 4 parts. Okay, so total of 4 parts. Okay, well, how far is it from negative 8 to 0? That's a total of 8. So the X parts goes by 2's, because 2 times 4 is 8. Y parts goes by what? From 8 to 0 is also 8. So 8 divided by 4 is 2. If you were to break them down into individual parts, every 2 coordinates in the X direction is 1 part. Every 2 coordinates in the Y direction is 1 part. Now it says from B to R is 2 parts. Okay, well, we just figured out how much each part is right there. Each one is 2, and so 2 times 2 is 4, and another 2 times 2 is 4. So we're going 4 away from B. Notice we have to start at B. We don't know how many. It tells me it's 2 parts from B, which therefore, obviously, if there's a total of 4 parts, it's also therefore 2 parts from A. You can figure that out. But since they gave us the B here, we'll start from B. Okay, that's why I started from B, 0, 0. Okay. And so I could just do this. I could say, okay, 0, 0, 0, I'm going 4 total units because that's 2 parts. 1, 2, 3, 4, and I'm going up 4. 1, 2, 3, 4. And there's my answer right there. That was B. This was A. And of course, it was also 2 parts from A, so there you see that's 4 and 4 also. Lands you in the same spot. Okay, it happened to be in the middle right there. Okay, but that was a little of a trickier one. Now, being that's a slope of -1, don't forget, the slope is -1 here, so I could count how many diagonals are and divide by a total of 4. Remember, there's 4 parts from A to B. 1, 2, 3, 4, 5, 6, 7, 8 diagonal. So 8 divided by 4 is 2. So every 2, 1, 2 is 1 part. 1, 2 more, and there's 2 parts away. Or 1, 2, there's 1 part. 1, 2, there's 2 parts away. Okay, so if it's nice, easy on the DCAS, for example, you can just do that. If it goes right through nice diagonals like that. Okay, so -4, 4 is that answer. Okay. Just, for what I have here, the 1/2, I reduce this 4 to 2 down to 2 to 1. Okay. You can reduce that if you want. And then so it's 1 part out of a total of 2 parts. Remember, that's not 2 parts away from A, that's 2 total parts. So it's 1 part away from B out of the 2 total parts. That's where that 1/2 is there. And then what was the total X distance? 8, and the total Y distance was 8. So that's where those 1/2 came from. I reduced right there. Okay, so I showed you multiple ways that you can do that problem. All right, another one, and this is why I want the assignment done when you come to class, because we'll practice more of these in class as well, is this one right here. Notice segment AB. So AB are the endpoints. Has endpoint of A, and instead of giving the other endpoint of B like it has, it's giving you the R instead. And then B, we have to find where B is. Point B lies on segment, lies on line AR. Okay. I didn't get the line in there. Okay. I was in line AR. Okay. So let's plot that here. -7, 6. Go to the back side again. -7, 6. 1, 2, 3, 4, 5, 6. That's A. R says what? R is -7, -6. Oops, pull it down more. -7, -6. 1, 2, 3, 4, 5, 6. There's R. Okay. So they go ahead and tell us what the ratio is, how many parts A to R is, and then we can divide that up, and then B has to be somewhere down here. Okay, because on that line, and R is on it as well. So B has to be somewhere down here. It cannot be obviously in front. It can't be up here because R is between A and B. So it can't be up in there. It has to be down on this side. It has to be somewhere down here. It has to be, B has to be somewhere down here, so R is in between. So just know that when it sets it up like that. Okay, so let's read how many parts it says it is. It says the length of R to B to A to R. Okay, well, the ones we have right now is A to R, right? We have the A and the R given us. So A to R, which is what we have, so I circle it, is a total of 4 parts. So we go ahead and figure out that distance from A to R and divide it into force. Okay, and that's how many parts 1Y is. Okay, so from A to R, how far is it? From -7, 6 to -7, -6 is a total of 12. And it's divided into 4 parts. So that means it equals 3 for each part. Okay, I'll change the color. So 1, 2, 3, that's 1 part. Change the color again. 1, 2, 3, that's 2 parts. Change the color again. 1, 2, that's 1, 2, 3, that's 3 parts. And we'll go back to green again. 1, 2, 3, there's my 4 parts. Okay, so every time I go 3, a total of 3 down, that's 1 part. And going back to read what it said, how far is B from R? How many parts is B from R, it says? From B to R, right here, is only 1 part. So I only have to go 1 part further down. Remember, every 3 was 1 part. So I go 1 part further down. 1, 2, 3, and there's where B is right there, which would be -7, -9. Okay, so B is now 1 part from R. Okay, so I think it only asks for the y coordinate, -9. Now, why would it do that? Because -7 is consistent for all of them. So they just wanted the y coordinate. -9 is my answer. Okay. So what I have shown here, the y, starting from R, -7, -6, because we know to B is 1 part. I'm going down. I'm going how many parts down? 1. And how much was each part? We already calculated it, 3. 12 divided by 4 was 3. And that gives you the -9 right there. Okay, I scrunched it in right here on the front side, but I showed it more clearly on that back one. Okay, right there. All right, number 5. Okay, this is back to our normal type that we've seen. We're identifying the 2 parts, the 2 points where R can be now. We use the same ratio. So we have to go from A and from B. The only thing that's going to change is our starting coordinates of A and B, and then our signs will change. So from A, plot -6, -9, put -6, 9 here. I'm going right, which is positive for the X, and then down to hit the line segment, so it's negative. I'm going to use the 1 out of a total of 4 parts, so that's why it's 1/4. And how long was this X distance right here from -6 to 6 is a total of 12. That's why you see the 12 in parentheses there. And of course, it's the same fraction, 1/4. And how many is the Y direction? Only 4. That's why you see 4 right there in parentheses. And now you do the calculations. 1/4 of 12 is 3 minus 6 is -3. And 4 by 4 is 1. 9 minus 1 is 8. And I can check that -3, 8 fits right on the segment. So that works. Now I'm going to do the exact same thing, but from B. So the only thing I'm changing is what the B coordinates are, 6, 5, and I switch the 2 signs. Okay? Because I'm going the opposite direction. Left on the X direction, which is negative, and up for the Y direction. The rest over here, this is exactly the same in both of them. That does not change. So 1/4 of 12 and 1/4 of 4. That's a 4 if you can't read it. Okay, so 1/4 of 12 is 3, 6 minus 3 is 3, and 5 plus 1 is 6, 3, 6. 3, 6 is that part right there. Those are both 1/4 of the way from A and from B. And so what are those points then? 3, 6, and -3, 8, right down here. I listed. So you can do this one, you can use this graph right here to do it from. Okay. All right, so now we need to graph the inequalities here. X greater than equal to -6, that's a solid line, vertical. X equals numbers always vertical. Greater than is to the right, so I'm shading on that side. Y is greater than 2, it's a horizontal line at 2 and it's dashed. I'm shaded above it because it says greater than, so now I'm up in this region right here. And then this is in point slope form. So I pull out the point. Remember it says x minus 2, and I always do the opposite of both those. So the opposite of minus 2 is plus 2. See, I'm pulling the point out, as it says, 2 comma 1. That's the point. So I plot 2 comma 1. I did right there. And then I pull out the slope. Slope is 3/2, which means up 3, right 2. I went up 3, right 2, up 3, right 2. Or I could use the -3 over -2, which means down 3, left 2. And all those points line up. Okay, I take my ruler, and since it's only greater than, as it says right there, it's only greater than, it's a dashed line. And it says greater than, so greater than is on the above side. So it has to fit all those conditions, which then puts it right here, above that line, to the right of that line, and above this line. Okay, so there's our answer. And you could check if you wanted to. If you weren't confident, you could pick a point in that region, and it should satisfy all 3 inequalities. Okay, number 8. The solution to the system's equations below is what? Round to the nearest hundredth if necessary. So I plug that in my graphing calculator. I plug that in my graphing calculator, and the y equals. Then I hit second calc, number 5, which is intersect. Okay, hit enter, enter, enter. That'll give me the first one. And I round to the nearest hundredth. And I do second calc number 5 again. I hit enter, enter. And on the third one where it says guess, move your cursor, use the right arrow or the left arrow to move it closer to the other point of intersection. And you do that, and you get the second point. Okay, so there'll be 2 blanks there. So there's going to be 2 answers. Round to the nearest hundredth. Number 9, state the possible lengths of the third side of the triangle given these 2. This is the triangle inequality theorem. Remember, I subtract the 2. 7 minus 5 is 2. And I add the 2. 7 plus 5 is 12. So it has to be between 2 and 12. What's the exact distance that 4 negative 1 is from the origin? That's the Pythagorean theorem. Okay, so you got a squared plus b squared equals c squared. If you need to, you could plot that. 1, 2, 3, 4, -1. And I just do Pythagorean theorem now. Draw my right triangle. And that's just as 4, so this is a 1. Obviously, c is my hypotenuse. I have 16 plus 1 is 17, and I have to take the square root. That does not simplify, so I leave it as square root of 17. You do not put it as a decimal, or you get marked down. Decast, you would get no points. You have to follow the directions. All right, point M is the midpoint of a segment of AB, the midpoint. So if A is -7, 2, and M, the midpoint, you could also plot this too and just do counting if I want to do that. 1, 2, 3, 4, 5, 6, 7. 1, 2, -7, 2, and -4, 3. -4, 3. Okay, so there's A, there's M, so then B has to be somewhere up there. Somewhere in that direction, okay? So I can just count using slope. How many did I go? -7, I went 3. 1, 2, 3, and up 1. Right 3, up 1. So I go right 3, up 1 again. And there is B. And what is that point? -1, 4. Okay, so what I did here, I said, okay, how far is it from -7 to -4? That's a +3. That's why I see +3 there. So that means I must add 3 again, do a +3. So what's -4 plus 3? That's the -1. How far is it from 2 to 3? That's a +1, so I must do a +1 again. 3 plus 1 is 4. So you can also just do that, but if you need to plot it and count using slope, you can go ahead and do that. Okay, backside. The line y equals -7x minus 1 is divided by a scale factor of 4 centered at 0, -4. What is the equation of the new line? Well, remember with dilations, the slope does not change, so we can always write y equals negative 7x right away again. The only thing that changes is the y-intercept. Now the difference here is it's not at the origin, so I can't just multiply 4 times negative 1 and get negative 4. That would be if it was at the origin. This is centered at 0, negative 4. So I ask myself, how far is it from negative 4 to negative 1? That's plus 3. So every time I add 3, I'm doing another scale factor. So that was a scale factor of 1. So I have 3 more of those for a total of 4, right? So 3 times 3 is 9. If you want to think of it that way, I have to add 9 more because I have to go 3 more. So what's negative 1 plus 9? That's 8. And now what I did negative 4. I started here since every one was 3. 3 times 4 is 12. So I started back down here at negative 4 and added 12 and got my 8 there. Either way will work. Okay. Number 16. Endpoints 4, negative 4, and 12, 16 is the image. So this is the image after a dilation of 1/3. Okay. CD, therefore, is 3 times that distance. The reciprocal of 1/3 is 3. So the image got 1/3 smaller. So therefore, to get back up to the original, I have to multiply by 3. That's the reciprocal always. Center at the origin, what is the length of CD? Okay, so what I can do is I can just find this length right here and then multiply it by 3. Notice it didn't say round to nearest tenth. Then I could do it in the calculator. So I need to go ahead and find the distance. So I said, how far is it? That's the distance formula or Pythagorean theorem. How far is from 4 to 12? That's 8. So it's like a squared. So 8 squared. How far from negative 4 to 16? It's a total of 20. That's like b squared. It's like saying a squared plus b squared equals c squared. And then so that equals 464. And then of course, don't forget that's c squared. So I had to take the square root. So that now is c. Okay, then I go ahead and simplify that. 4 goes into 64, so 4 is going to go into 464. 4 times 116, well, then the square root of 4 is 2. And 116 simplifies because 4 goes into 16. So I have 4 times what is 116, 29. And then don't forget, the square root of 4 is 2 again. That's 2 again, so 2 times 2 is 4 right here, square root of 29. That's a 9 if you can't read it. So that's what the length of the image is. But don't forget, we want the pre-image CD, so we have to multiply that by 3. That's why you see this 3 out front. So 4 times 3 is 12 root 29. Okay, so it's dealing with Pythagorean theorem, reducing your radicals, and then multiplying by the reciprocal to get back up to the original. All right, 17. The line formed, that line is transformed by dilation of 4 centered at the origin. So this is the easier one. It's at the origin. So again, I have to solve for y. So divide each term by 2. I get y equals negative 2x plus 5. The slope does not change. So that part stays the same. Y equals 2x. And I just multiply the y-intercept by that scale factor. 4. 5 times 4 is 20. So there's my answer. We'll do number 18 next. What are the coordinates of this? There's P. So first, remember, this is a little circle there. So that's means dilation of 4 following a reflection over the line y equals x. Well, you should already know by now, when I reflect over the line y equals x, I switch the x and the y, which is what I have right here. Switched them. And now I do dilation of 4, which means just multiply each of those coordinates by 4. And that gives me that answer right there. All right, we'll do 19. What's the slope of the image of the line after a dilation of a scale factor of 8 centered at the origin? Well, what's the slope? What do we know doesn't change? The slope. So there is the slope. 2 over negative 8, which simplifies to negative 1/4. Always simplify it. Okay. 20 is find the center and exact radius of the circle. So we move everything to one side except for the constant can stay over here. Put the x's together, so I have x squared minus 8x. Don't forget you're subtracting across. I take half of b squared, remember? You already know that, inside and out. So half of 8 is negative 4 squared. is 16. There is no y, so it's just y squared, so it's at 0 there. And so I added 16 to it, so I must add 16 to the right side. Don't forget, then this factors into x minus 4, right there, quantity squared plus y squared, and 12 plus 16 is 28. So the center is 4, 0. Radius is the square root of 28, which breaks down to 4 times 7, which then gives you 2 root 7 for your final answer. Okay. Write the equation of a line that's perpendicular bisector of a segment with endpoints negative 4, 4, and 5, negative 4. So perpendicular bisector, again, this is guaranteed to be on the DCATs. It's been every year. One of the highly missed ones. Bisector means midpoint. So I take the midpoint, find the midpoint, and that's going to be my new point I'm going to use. So remember, midpoint, add the x's, divide by 2, add the y's, divide by 2. So that gives me 1/2, 0. Then I need to find the slope, because perpendicular, remember, it goes along with slope, and that's the negative reciprocal. So I need to first find this slope, which is right here, changing y over changing x. Okay, doesn't matter which way you go, I went this way. So I get 8 over negative 9. That's the parallel slope. I want the perpendicular slope, which is the negative reciprocal. So the negative reciprocal of negative 8/9 is 9/8. So there's the slope I'm using with that point. Okay. And so I went ahead and put it in point slope form. Doesn't say, it says write equation of a line. Doesn't say what form it has to be in. So the easiest is point slope, since I have a point and a slope. So y minus 0, which is just y then, equals the slope 9/8 times the quantity x minus the x coordinate right there. Now, if you want to go ahead and solve for y, you distribute the 9/8 through there and you get y equals 9/8 x minus 9/16 if you want to put it in slope intercept form. Sometimes they might have a slope intercept form, ask you to do that. So don't forget, you would just solve for y after that. And last one, no, 2 more to go. In a coordinate plane, the locus of points 8 units from the point. Whenever it's from a point, that is the center right there. And that is the radius right there. So we just put it into the circle, standard circle equation. X minus the x coordinate, so x plus 8 quantity squared, plus y minus the y coordinate 2 quantity squared equals the radius squared. Don't forget this radius squared, so 8 squared is 64. And last one on locus. Again, you're going to have one locus problem on the DCAS. You just don't know what type. It could be a circle one like that, or it could be a line one like this one. In the coordinate plane, the locus of all points that are equidistant from the line y equals 9 and y equals negative 5. Well, those are two horizontal lines. So therefore, it's going to be another horizontal line right in the middle of those two. Well, so how far is it from 9 to negative 5? That's a total distance of 14. So what is half of 14? 7. So I can either do 9 minus 7 to get the 2, or I can do negative 5 plus 7 to get the 2. And so the equation of the line is y equals 2. That's the line directly in the middle between y equals 9 and y equals negative 5. All right, so come to class with questions or any problems that you want more practice on it. And after we go over anything from here, then we will practice more of any of these types of problems. All right, that'll do it.